Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good morning to all. I hope all of you are well prepared to study this course. Okay, make sure you have your own notes. Now we look at the lesson outcome first. So chapter 2.0 is all about the step growth polymerization, whereby we will discuss about the characteristic, the chemical structure of polymer that can produce by step growth polymerization. We also will learn about how to achieve the high molecular weight of the polymer in step growth polymerization process. And we will cover about the gelation, the mechanism process, the differentiate between the catalyzed and uncatalyzed polymerization, and also the kinetic study of the polymerization, dP or degree of polymerization, stoichiometry imbalance, and also the P extent of reaction, and N is the number of mole, and N naught is the number of mole that is unreacted, and also PDI, which is polydispersity index. Okay, now we look at the first slide. Traditionally, polymerization reaction have been classified into two main groups proposed by the characters, which are condensation, polymerization. Okay, if we look at the structure below, is the preparation of the nylon 6,6. Involve the reaction of the hexamethylene diamine and adipole chloride. So hexamethylene diamine is given by NH2, and at the end of the both structure, right? We have NH2, and we have not adipole chloride. We have the adipic acid, which have OOH group at the monomer structure, both at the end of the monomer structure. So it will give the nylon with the number of N, either nylon 6,6, nylon 610, right? 6,7, and 6 and 10 represent 6 is represent the number of methylene group in the diamine portion, while for the 10 is the number of the carbon atoms in diacyl portion. So in condensation polymerization, as we can see here, it will produce a byproduct, which is water. We have HCl or other product. So it must have a product, byproduct. So it is a process to produce a polymer contain fewer atoms as the monomer in its repeating units due to the formation of byproduct during the polymerization process. And secondly, we have the addition polymerization, which is a process to produce a polymer containing the similar atoms as the monomer in its repeating unit. So basically, we have condensation and addition polymerization. So for condensation polymerization, it is a step growth polymerization. For addition polymerization, it is a chain growth polymerization. Okay. But there is a certain case whereby addition polymerization can be produced via step growth polymerization. Okay, for example, the preparation of the polyurethane. Okay, for the addition polymerization, the monomer must have a double bond. So the chapter about the addition polymerization can be produced by chain growth polymerization. We can study details in chapter 3. Okay. The characters classification into the condensation and addition polymers is no longer valid for its intended purpose because of the many advances in technology since the idea was proposed. Therefore, the polymerization reaction are now commonly classified according to the polymerization mechanism. Okay, so that the previous slide is on the general description, whereby how the scientists classified the step and chain growth polymerization. Alright, so step growth polymerization is a process of building of the polymer chain in a stepwise fashion by random union of the monomer molecule to form dimer, trimer, and higher species throughout the monomer matrix. So it means that to produce the polymer by using the step growth polymerization, the monomer is stepwise fashion, is step by step by random union which is by random reaction of the monomer between the monomers. While for the chain growth polymerization, it is a process to build a polymer from the very beginning of the reaction. Okay, starting from the double bond of the monomer, uh, and it will react to itself and the presence of an initiating monomer molecule to link to the end of a growing chain. So in chain growth, it requires the presence of the initiator. Hence, the process of the chain growth polymerization, it can produce high molecular weight reaction at the beginning of the reaction compared to the step growth polymerization, whereby it can produce high molecular weight polymer at the end of the reaction. So step growth will take quite more time compared to the chain growth polymerization. The reaction that involve a random reaction of two molecules that may be any combination of a monomer, oligomer, or a long chain molecule. And as the name implies, step growth polymers are formed through a series of steps. So this is a definition of a step growth polymerization. Okay, so it can be any combination of a monomer, right? So it cannot be a single monomer. Okay, it must be any combination of the monomer. And so each step involves reaction of two functional groups. High molecular weight material result from a large number of steps. Any two molecular species in the mixture can react, at least any two molecular, okay, which is any two molecular means that any two monomer, right, or two functional group, which the reaction with the suitable functional end group often proceed without the need for catalyst. Okay, so it is a self-catalyst reaction. Okay, and the group of the polymer molecule proceed by a stepwise intermolecular reaction. And during the reaction, molecule of variable length coexist. And the molecule participating are monomer, we have the oligomer, and also the polymer. So all species can react. And the molecule grow throughout the entire reaction time according to the random collision. Usually, linear chains are produced. Okay. For example, of the linear polymers such as PE, right, polystyrene. And the activation energy of rate is about the same for each in the reaction mechanism. Okay, activation energy is the energy required to produce the reaction. Okay, and the average molecular weight will increase steadily with the reaction time. Long reaction time are usually necessary to produce high molecular weight reaction compared to the chain growth. It required less time. And the equilibrium reaction, it can go up to 99.9% of the completion. And a minimal condition to synthesis polymer must have biofunctionality of both reactant, means that it must have two functional group, right? And reversible reaction, whereby it is a reversible reaction, means that the reaction can be reversed, right? It can react with the water. So we need to remove the water from the reaction mixture to increase the conversion. As I showed in the previous slide, the preparation of the nylon stick, it produces water, right? So the water, it can react with the monomer back again and again, and this will affect the percentage of the conversion of, or also known as the yield of the polymer produced. So we need to remove the water. High conversion of the functional group in order to obtain the high molecular weight polymer. Okay, this one is the graph for the mole fraction conversion. P is a conversion, okay, and Xn is a degree of polymerization. Okay, P also known as a mole fraction monomer conversion. So we have so many definition for P. Okay, Xn is a given by 1 over 1 minus P. Xn is the degree of polymerization. So 1 over 1 minus P. As we all know, that xn here, when p is 1, xn is increased, alright, almost 1000. And the value for p, it cannot be more than 1, it must be less than 1. Monomer molecule disappear very quickly, okay, during the reaction process of the step growth polymerization. And the polymerization rate will decrease steadily as functional group consume. Means that when the reaction, at the end of the reaction time or during the reaction time, the polymerization rate, it will decrease slowly, okay, when all the functional group has been consumed. All the functional group has been consumed. Typically, small molecules are produced at each reaction as a byproduct. As you can see here, the preparation of the acetic acid with the ethanol, it will produce the ethyl acetate and also the water. But not all the step growth synthesis are condensation polymerization. Okay, for example, like I mentioned before, the preparation of the polyurethane. A number of different chemical reactions may be used to synthesize the polymeric material by step polymerization. These include the process of the esterification, okay, to make the unsaturated polyester, the amidation, the process to produce the nylon, formation of the urethane to produce a polyurethane, and the aromatic substituent, and so on. Okay. So all step polymerization, it fall into two groups depending on the type of the monomers employed. We have type 1 and type 2. So in type 1, it involves two different bifunctional and or polyfunctional monomer in which each monomer possesses only one type of functional group. So we call it as a polycondensation. So polyfunctional monomer means that it has more than two functionality. Okay, means that dalam satu monomer tu dia ada lebih daripada dua functional group. For example, if you have a nylon structure, just I given just now in previous example, you have NH2 at the end of the both monomer structure, right? So NH2 at the first monomer means that kalau dia punya functional group, functional monomer, functionality dalam satu monomer tu lebih daripada dua, kita consider dia sebagai polyfunctional. Kalau NH2 tu kita consider sebagai bifunctional. So a monomer with more than one functional group per molecule. For type 2, involve a single monomer containing the both type of functional group. We call it as the self-condensation. So bifunctional means that monomer with two functional group per molecule.